Welcome Algebra 2 students to week 6 of distance learning. This week we're going to be jumping into more of trigonometric functions. And this week we're going to be talking about one of the most quintessential topics in trigonometry, which is the unit circle. Many of you remember those unit circle projects throughout my classroom. Well, that's what we're going to be looking at today with this lesson. With that being said, let's get started with the notes I have up here on the board, the important notes for this lesson. So this lesson is titled Trigonometric Evaluations and the Unit Circle. When dealing with trigonometric evaluations in an ordered pair form, what you're going to notice is that the sine of theta is equal to the y value over the radius, or y over r. The cosine is the x over r. And then the tangent is y over x. And then the three inverse functions, the cosecant of theta is r over y, the secant of theta is r over x, and then the cotangent of theta is x over y. So if you're given an ordered pair, you would have the x and the y, and then you can use your distance formula to find what the radius would be. So x squared plus y squared and then square root. We'll look at an example of that here in just a little bit. Next we have the quadrantal angles, which is angles that are on the x or y axis, and then reference angles, that is the angle made with the x-axis. And then finally, what you see up here in the main portion of the board is the unit circle. You can also see this referenced on page 832 of your textbook, or you could type in Google unit circle and you'll see a representation of this circle. With the unit circle references a lot of the information we've talked about in this unit so far, dealing with the 30, 60, 90 triangles and the 45, 45, 90 triangles, because a lot of those same answers are replicated throughout this circle. So your square root of 3 over 2, the 1/2, the square root of 2 over 2, we did that in a problem previously. So when you're dealing out this unit circle, okay, unit circle means that the radius or the length of each line on this circle is 1. So when you're drawing this out, the x-axis and the y-axis, the x-axis comes over to 1, 0 and negative 1, 0, and the y-axis goes up to 0, 1 and 0, negative 1. And then of course, referencing last week when looking at angles, you're starting here on the positive x-axis at 0 degrees. Then you go up to 90 degrees. Then you go over to 180 degrees. And then you keep going to 270 degrees. And then you make your way all the way back to 360 degrees. Now you will notice increments that happen in this unit circle. So from 0, we go up to 30 degrees, then to 45, then to 60, and then up to 90. So every quadrant on this will have that same pattern. 30 degrees, 15, 15, and then 30 degrees. So 0 to 30, 30 to 45, 45 to 60, and 60 to 90. And then you have 120 degrees, 135, 150, and then 180. There again, 30, 15, 15, 30 again. And then for the next quadrant, you have 210, 225, 240, and then 270. And in the final quadrant, you have 300, 315, 330, and then 360. What you see next to each degree measure is the radian conversion. We did radian conversions last week, and so the same thing would happen if you wanted to convert any of these into radians. You would take 30 over 180, simplify it, and put the radian there. So 30 over 180 is 1/6. So you put the radian, and so it's radian over 6. 45 is 45 over 180, so 1/4. So you put radian over 4. For 60, it's radian over 3. For 90, it's radian over 2. For 120 degrees, it converts to 2 radians over 3. For 135 degrees, it converts to 3 radians over 4. For 150 degrees, it converts to 5 radians over 6. For 180 degrees, it converts to 1 radian. 210 is 7 radians over 6. 225 converts to 5 radians over 4. 240 converts to 4 radians over 3. 270 converts to 3 radians over 2. 300 converts to 5 radians over 3. 315 converts to 7 radians over 4. 330 converts to 11 radians over 6. And then 0 in the 360. 0 is 0 radians, and 360 is 2 radians. Now you're going to notice that the ordered pairs are at the end of each one of these lines. These are the perfect ordered pairs utilizing those 30, 60, 90 triangles and 45, 45, 90 triangles. That's why when we did those examples, and you can go back and look at those videos, I used 1 for the hypotenuse for that reason, so that we would see where we're coming up with these numbers for the unit circle. So for 0 degrees, it's 1, 0. For 30 degrees, it is square root of 3 over 2, comma, 1/2. For 45 degrees, just like we did in previous videos with the 45, 45, 90, we come up with square root of 2 over 2, comma, square root of 2 over 2. 60 degrees, that ordered pair is 1/2, comma, square root of 3 over 2. You'll notice that it is just the switched form from the 30 degrees. 90 degrees is 0, 1. Now you'll notice from here on out that all of 3 of these ordered pairs will just be changing signs as we go to each quadrant. They're going to be changing signs. So for this next one, 120 degrees, it's the same spot, just a negative x from our 60 degrees. So for 120 degrees, it is negative 1/2, comma, square root of 3 over 2. 135 is negative square root of 2 over 2, comma, square root of 2 over 2. 150 is negative square root of 3 over 2, comma, 1/2. Next, 180 degrees. That is negative 1, 0. For 315, it is square root of 2 over 2, comma, negative square root of 2 over 2. For 330 degrees, it is square root of 3 over 2, comma, negative 1/2. And then back around at 360, it is 1, 0. Now that's a lot to take in one piece of notes. But I do want to write a couple things down here below it just to let you know that it's a good reference for these things, because in the unit circle, we're dealing with a radius of 1. So if you think about these formulas from the top, they become so sine of theta is y in the unit circle, cosine of theta is x in the unit circle, and then tangent is still y over x. Cosecant is 1 over y, secant is 1 over the x value, and then cotangent is x over y. So this is going to help us as a reference for the rest of this lesson, and we are now going to look at a few examples dealing with each piece of notes that you see up here on the board. Now let's look at the examples for this lesson. We have 4 examples that we're going to look at. Example number 1, the terminal side is at -6, 2 in the standard position. We're going to find the 6 trig values. This is referencing the top part of the lesson notes. Example 2, find the 6 trig values for -2, 0. Again, referencing the top of the lesson notes. Example 3, sketch the angle and then find the reference angle. So we're going to be dealing with the reference angle definition that we had in the middle of the notes. And then example 4 is evaluating. We're going to use the unit circle to evaluate these final 2. Example 1. The terminal side is at -6, 2 in the standard position. Find the 6 trig values. Now, we had all 6 trig value formulas written at the top of the lesson. What we have to do is we have to find what R is before we can go in and plug them in. To figure out what R is, we have to use our distance formula, or square our x plus the square of our y and square root. So R equals the square root of -6 squared plus 2 squared. -6 squared is 36, 2 squared is 4, so (36) and 4 make 40, and so we have the square root of 40, or if you broke the square root of 40 down, you could use 2 square root of 10. So how I did that was I broke down 40, I had 10 and 4, 4 breaks down to 2 and 2, so I circled the pair of 2's and pulled it out. And you were left with a 10 underneath. So square root of 40 or 2 square root of 10. Now we're ready to plug those into each one of these 6 trig formulas that I gave you at the top of the lesson notes. So starting with sine, sine is 2 over 2 square root of 10. The 2 and 2 would simplify, so 1 over the square root of 10. And then the reason why I wanted to do this example is if you're left with something with a radical on the bottom, the very final step is to rationalize the denominator. So multiply by the square root of 10 on top and bottom. So it becomes the square root of 10 over 10. Cosine, that is x over r, which is -6 over 2 square root of 10. -6 over 2 square root of 10 is -3 over the square root of 10, which we would then rationalize. Multiply by the square root of 10 on top and bottom, and we would get -3 square root of 10 over 10. And that is the cosine. Tangent is y over x, or 2 over -6, and 2 over -6 reduces to -1/3. Then our cosecant is r over y, or 2 square root of 10 over 2, 2 square root of 10 over 2, or simply square root of 10. Next would then be our secant. Our secant in this case is r over x, which means the 2 square root of 10 over negative 6. And then it reduces. So the square root of 10 over negative 3. And then the last one is the cotangent, which is x over y, which is negative 6 over 2 in this case. And negative 6 over 2 reduces to negative 3. So when you're looking at this, the final answer, sine, is square root of 10 over 10. Cosine is negative 3 square root of 10 over 10. Tangent is negative 1/3. Cosecant is square root of 10. Secant is square root of 10 over negative 3. And then cotangent is negative 3. So watch the two most difficult steps, which is breaking down the radical if you have to, and then rationalizing the denominator if you see it on the bottom. Other than that, most of these examples and problems from the assignment will be straightforward, dealing with just plain whole numbers. So you'll notice from your assignment this week that 3 will have radicals in them that you'll have to rationalize or break down. The rest should not and should be dealing with whole numbers. Example 2, find the 6 trig values for the ordered pair negative 2, 0. So similar to the first one, except for this time negative 2, 0. The first step here is to find r. R in this case is 2 because the square root of negative 2 squared plus 0 squared is the square root of 4, which is 2. So now we go through our sine and all 6 of our trig formulas. So sine is 0. Cosine is negative 1. Tangent is 0. The cosecant is 2 over 0, which means that it is undefined. The secant is negative 1. And then finally, the cotangent is undefined. Anytime you're given a 0 in the denominator, it is always going to be undefined. And that finishes up example number 2. Example number 3, we're dealing with sketching the angle and then finding the reference angle. We're going to sketch each angle in the standard position, so that means that one ray will be on the positive x-axis. Since the angle that we're sketching is negative, we're going to be going from the positive x-axis down 110 degrees. So it would be past 90 and it'd be 110 degrees in that direction. So that's why we drew the first ray on the positive x-axis and then drew the negative 110. So it went down 110 degrees and it's over here in quadrant 3. So we've sketched the angle, now we're going to find the reference angle. The reference angle is the closest angle measured to the x-axis. So since we're sitting down here at 110 degrees, that means the closest it is to the x-axis will be on the negative side. It'll be closest to that negative side of the x-axis, and it's going to be a measure of 70. Because it is closest to that negative side of the x-axis, and it's only 70 degrees away from that x-axis. Now let's look at another one to make sure we kind of understand this concept and idea. The next one is B, which is 2 radians over 3. If you'll remember your unit circle that we drew up at the bottom of our notes, we had a line that actually used 2 radians over 3. It was at 120 degrees. So what you see here is the angle, which is 2 radians over 3, or 120 degrees. And you'll notice that the closest x-axis is this negative x-axis. So what we need to do is figure out what that angle is, because that angle is the reference angle. So to figure out what this angle is to the negative x-axis, you utilize 2 radian over 3, or 120 degrees, and you're going to 180, or 1 radian. So this angle has to be the difference between the two. So radian minus 2 radians over 3, or 180 minus 120. So radian over 3, or 60 degrees. That's the reference angle for part B. Now we move on to example 4, where we're going to evaluate utilizing our unit circle. The first one, part A, says the cosine of 135. So you go to the unit circle at 135 degrees. You'll notice at the end of that line at 135 degrees, there's an ordered pair. Now the cosine that we wrote below our unit circle said that we're going to use x. So we go to 135 on the unit circle. Okay, we go to 135. We look at the ordered pair. Since cosine is the x value at that spot is the answer. So for this one, cosine of 135, it's negative square root of 2 over 2. Now, noticing how fast we did that, that's the reason why the unit circle is important. It will allow us to evaluate much faster. And then part B, the tangent of 5 radians over 6. So we go to 5 radians over 6, and then because it's tangent, we do y over x. So 1/2 divided by the negative square root of 3 over 2. Because we're dividing fractions, you're going to remember the keep flip change. 1/2 times negative 2 over the square root of 3. 1/2 times negative 2 over the square root of 3 becomes negative 2 on top, and then 2 square root of 3 on bottom, which the 2's would cancel. And we'd be left with negative 1 over the square root of 3. Now, to finish this off, we do have to rationalize the last piece of this. So we multiply by the square root of 3 on top and bottom, and we get negative 1 square root of 3 over 3. That finishes up the last example for this lesson. So what you're going to see now is the assignment posted below. As always, please feel free to reply, post, chat, email, questions. I'll be glad to answer your questions. I'm going to be praying over each and every one of you this week. I hope that each and every one of you have a great week, and I hope to see you guys really soon.